1997 number 6 is a periodic trends question. So they want us to explain each of the following based on our understanding of atomic structure and or bonding. And so when we're doing this, you remember the rules. We got to decide, first of all, is what we're looking at an effective nuclear charge situation, or a shielding situation, or an electron-electron repulsion situation. Because that'll help us kind of narrow in on an argument. Usually it's one of those three. I suppose it could be more than one, but usually it's one of those three. We're going to base our argument on specific statements about number of particles. We need to identify something in the atom that we're going to use as evidence for our argument. And then, of course, we're going to mention both atoms. We're not going to imply or infer much of anything. And the one I didn't put in here is we got to make sure that we actually answer the question. So I'm going to make an argument here, and then we'll see if we can find those things in it. Alright, so let's look at this. Now, you probably could do this shorter than I've done it here. You certainly would not want to go longer. Potassium has a lower first ionization energy than lithium because the valence electron, this is really important, we're saying we understand which electron gets removed when it's the first ionization energy. Anyway, the valence electron removed from K is shielded by 3 shells. There's our specific statement about number of particles in some way. So K is shielded by 3 shells of core electrons, whereas lithium's valence electrons are shielded by only 1 core level of electrons. The reduced attraction experienced by K's valence electrons results in a lower first ionization energy. So this is kind of my conclusion. This could be picked on as well, and I'm sure a few of you are thinking about that. But generally speaking, if you mention specific numbers about showing your understanding of what the key difference between the two of them is in the atom, usually that's enough. You notice I made a shielding argument here without ever using the term shielding. Well, actually, I sort of did right there. But you don't have to mention it. And as a matter of fact, you wouldn't want to just say, "Oh, it's because of shielding," and go on, because you haven't provided any proof for why it's shielding. So knowing the term is helpful, but it's not everything. And lastly, I mentioned both atoms and said something specific about them. So I think that that's a reasonable argument. If you were sitting here wondering, could I make a Coulomb's law argument? As in, could I say, well, that potassium was 3 rings out, and the R, the distance between these, would be greater? Yes, I think in this year's test you could probably get away with that. But you'd probably have to write out Coulomb's law and talk about, the R is much greater here, and so the F on this side, the force of attraction would be reduced. I really think that would work this year. In the past, it probably wouldn't have.